Compression mode. First, compression mode is an old and widely used molding process for thermostatic plastics. Next, molding compounds include powder or pellets, liquid or preformed. Applications include rubber, tires, and polymer matrix composite parts. Amount of charge must be precisely controlled to obtain repeatable consistency in the molded product. Material can be produced by compression mold. First, melamine, phenolates, epoxies, urethanes, elastomer, and urea formaldehyde. Below is an example of compression mold.
This is an extruder machine. The one shown right now is a single screw extruder machine that is usually used in the industry for plastics and elastomers. Right now I'm showing you the cross section of the extruder machine. There are two main parts. One is a barrel, the one I'm circling right now. The second one is screw. So these are the two main parts which is in the extruder machine. There is another important component in the extruder machine, which is die. It is a tool that must be fabricated for a particular profile to be produced. There are plenty of advantages of using the extruder machine. One is low cost, flexibility of operation. In hot extrusion, post-execution alterations are easy because product is still in heated condition. Next is high production volumes, continuous operation. Many types of raw materials can be used. Good mixing, and surface finish obtained is good. Next, we are going to see the parts in injection molding machine. This is an injection molding machine that is used widely in the industrial use. This is a cross section of the injection molding machine. It is divided into two parts. One is the injection unit. The purpose of the injection unit is to melt and deliver polymer melts, and it operates much like an extruder. The second part is the clamping unit. It opens and closes mold each injection cycle. The advantages of the injection molding machine is it is usually for detailed features and very complex geometry. It is also high efficiency, enhanced strength, and it then has the ability to use multiple plastic types simultaneously. Extrusion blow molding. The one shown in picture is usually used in the industry. This is the extrusion blow molding. One of the labeled parts is Parison, the extruder barrel, tube die, and blow pin. The advantages of the extrusion blow machine is due to lower pressure, the mold costs in extrusion blow molding are lower as compared to injection molding. Next, the machinery costs are low. It is easy to mold external threads. Next is making open-ended parts that are large can be done by splitting open closed molding. Injection blow molding. This picture shown is exactly what the injection blow molding looks like in industrial use. Injection blow molding parts uses a blowing stick. The advantages of using the injection blow molding is no unwanted scrap material is generated during the process. Next, better, tighter part tolerances that are safe and secure are created. The procedure produces good surface finishes. Injection blow molding yields a high product volume. Compression molding. The machine that you're seeing right now is a compression molding machine that is widely used in the plastic industry. The components in the compression molding machine is the upper mold, which is movable, the lower mold, which is fixed to the machine, and an injector pin, which is used to remove the product from the machine, from the lower mold. The advantages of the compression molding machine is the loss of raw materials is small and will not cause too much loss, usually around 2 to 5% of the product quality. Next is the internal stress of the product is very low. The warping deformation is also very small, and the mechanical properties are relatively stable. Thermoforming. The thermoforming machine, which is shown in the picture, is the one that is usually used in the plastic industry. The thermoforming parts is only the heater, clamps, mold cavity, the mold, vacuum holes, and the plastic sheet. The advantage of thermoforming is low tooling costs relative to injection molding. Next is parts with very small thickness to area ratios can be fabricated. Extremely large parts can be fabricated.
First of all, compression molding is the process of molding in which a preheat polymer is placed into an open heat mold cavity. The mold is then closed with a top lock and compressed in order to have the material contact all areas of the mold. Next is this process is able to produce parts with a wide array of length, thickness, and complexities. The objects it produces are also high in strength, making it an attractive process for a number of different industries. Thermoset composites are the most common type of material used in compression molding. 4 main steps. First step is a high-strength 2-part metallic tool is created that exactly matches the dimensions required to produce the desired part. The tool is then installed in a press and heated. Second step is the desired composite is preformed into the shape of the tool. Preforming is a crucial step that helps to improve the performance of the finished part. Third step is the preformed part is inserted into the heat mold. The tool is then compressed under very high pressure usually ranging from 800 psi to 2000 psi, depending on the thickness of the part and the type of material used. Fourth step is the part is removed from the tool after the pressure is released. Any resin flash around the edge is also removed at this time. Then disadvantages of plastics compression mold. First is complicated. Second, the investment is large. Third, the compression machine is limited.